Hello everyone. Today we'll discuss exercise 14.1 question number 7. State the number of lines of symmetry for the following figures: an equilateral triangle, B an isosceles triangle, C an scalene triangle, D a square, E a rectangle, F a rhombus, G a parallelogram, H a quadrilateral, I a regular hexagon, J a circle. Right? Let us find. First one is an equilateral triangle. If we draw a triangle, if we draw an equilateral triangle, this is the figure's name. This is figure's name. Figure's name. This is the diagram with symmetry. Diagram. Diagram with symmetry. Symmetry. Diagram with symmetry. And this one is number of lines. Number of lines. First one is equilateral triangle and equilateral triangle. Equilateral triangle and equilateral triangle. Equilateral diagram with symmetry. Diagram with symmetry, that is, if we make a triangle here, the equilateral triangle, this is an equilateral triangle, and if we draw the various symmetrical lines, here you can find symmetrical lines can be drawn with the help of a scale. Let us draw the symmetrical lines. The first line can be drawn here as, this is the first line, this is the vertical line, this is one symmetrical line. You see, this is one symmetrical line, right? And the second symmetrical line can be drawn here in this way, that is this one. That is this one. That is another symmetrical line. And here also you find another symmetrical line, that is in this way. Another symmetrical line, right? Therefore we got three symmetrical line, right? Therefore the number of symmetrical line is 3. Number of symmetrical line is 3. Here you see, that is 3 for an equilateral triangle, right? Now an isosceles triangle. Now if we draw an isosceles triangle, let us draw an isosceles triangle. Number B is an isosceles triangle, and isosceles triangle. Isosceles triangle. If we draw an isosceles triangle, then here you will find here we are drawing an isosceles triangle. That means both the sides are same. Suppose this one, okay, here we are drawing a triangle that is isosceles. That means if suppose this triangle is same only, this side is equal to this, this side is equal to this side, right? Therefore, there is only one line of symmetry. Okay, if we draw lines of symmetry, you will find that is in isosceles triangle there is only one line of symmetry. Let us draw this line of symmetry for this isosceles triangle. Here you see that you will get only one line of symmetry, right? Here see that is one line of symmetry, that is number of line is one only. Okay, I'll find question number C is an scalene triangle. Let us find the scalene triangle, right? Let us find the scalene triangle. Now we finding the scalene triangle. Suppose let us find the scalene triangle. Question number C. Question number C. Question number C is, let's find question number C, an isosceles triangle, right? Let us, you have to remove, you have to remove this one. Let us rub this one. Let us rub this one. Right. Now, question number C is an scalene triangle. If I draw an scalene triangle like this, question number C, and a scalene triangle, and scalene triangle, a scalene, S C A L E N E, scalene triangle, scalene triangle. If we draw a scalene triangle, then here you find the scalene triangle is like this. If we draw a scalene triangle here, that is a triangle like this. Suppose this is scalene triangle, that all the sides are not same. That is scalene triangle. Here this is a scalene triangle, and you see there is no line of symmetry, right? There is no line of symmetry. This is the figure's name. This is the figure's name. Figure name. Figure name. It is diagram of the figure. Diagram. Here the number of lines of symmetry. 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 Here you find the number of lines. Number of lines of symmetry. Number of lines of symmetry is equal to 0 for scalene triangle, right? Now question number D. Question number D is a square. If we draw a square, what will find? If we draw a square, here you see we are drawing a square here. We are making a square. Here this is the square. We find this is a square, right? And if we make the symmetrical line, let us find the symmetrical. One is horizontal line. This is the symmetrical line about the horizontal. This is one line of symmetry. This is vertical, and you can also draw a horizontal line of symmetry. This is horizontal line of symmetry. This is horizontal line of symmetry, right? And you can also draw the diagonal also. Let us draw the diagonal. Here you see this is the diagonal. This is the diagonal line of symmetry. This is the diagonal diagonal, and this one is also diagonal. This is also diagonal line of symmetry. This one is also diagonal line of symmetry. This is also diagonal line of symmetry. That means there are 4 lines of symmetry. Okay, here you see 1, 2, 3 and 4. Therefore, there are in square, in case of square, there are 4 lines of symmetry. Right? In case of square, there are 4 lines of symmetry. Right? In case of square, the number of lines of 4 is 4. They will write here as 4. Okay? I will solve the next question number E. Question number E is a rectangle. Right? Let us rub this one. Right? Now we'll solve question number E, that is a rectangle. Now a rectangle. Question number E is a rectangle. Let us draw question number E. It is a rectangle. A rectangle. A rectangle. Let us place this scale here. If it is a rectangle is question number E, rectangle, and question number E, F is a rhombus. F is a rhombus. F a rhombus. A rhombus. Now let us draw a rectangle. If I draw a rectangle here, you see, if I draw a rectangle, then we are getting this rectangle. And if we draw this rectangle, let us delete this one. This is a square actually. Let us delete this one. Now let us draw a rectangle here. This one is a rectangle here. Right, this is a rectangle. Now here in this case also, you see there are 2 lines of symmetry. Right, you see one is horizontal and another is vertical. In this case, you will get 2 lines of symmetry. But this one, right, this is one is horizontal and another one is vertical. Another one is vertical lines of symmetry. That is, in case of rectangle, there are 2 lines of symmetry. One is horizontal and another one is vertical. Right, this is the vertical line of symmetry. You see, this is the vertical line of symmetry. That is, in this case, there are only 2 lines of symmetry. Right, now number of lines of symmetry. Number of lines of symmetry. Number of lines of symmetry. Number of lines of symmetry is 2. Number of lines of symmetry is 2 in this case. If we take a rhombus, then what will happen? Let us take a rhombus here. Rhombus means all the sides are of same length. Right. Let us take a rhombus. Now we'll take a rhombus. Let us take a rhombus. If we take a rhombus here, let us take a rhombus here. We have taken a rhombus here. Let us find the line of symmetry. If we draw a line of symmetry in this diagonally, then we'll get the line of symmetry as diagonal. Here you see, this is one diagonal. This is one diagonal. And there is another diagonal also, like this. Right? There are 2 diagonals here, this one and this one. That is, number of lines of symmetry is 2 here. In case of rhombus, the lines of symmetry is 2. right? Therefore, here we are writing the lines of symmetry for rhombus is 2, right? Now solve question number F. Now Z, parallelogram. Now if you take a parallelogram, what will happen? You see, suppose if we are taking a parallelogram. Now if we take, next question is G, a parallelogram, a quadrilateral. Let us take G, a parallelogram, a parallelogram, parallelogram, and H is a quadrilateral, a quadrilateral, 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 a quadrilateral, right? Let us first find the parallelogram. If I take a parallelogram, you see here, we are taking a parallelogram, then let us take a parallelogram. Suppose this is a, we have taken a parallelogram like this, okay? This is a parallelogram, right? In case of parallelogram also, we are finding, in case of parallelogram, we will find here that in case of parallelogram, suppose this is a parallelogram, right? Here you find that there is no line of symmetry. If you draw the diagonal, there is no line of symmetry. Therefore, in case of parallelogram, lines of symmetry is 0, right? In case of parallelogram, lines of symmetry is 0. Number of lines of symmetry is 0. You see here, that means there is no line of symmetry, right? That means line of symmetry. If we write here that line of symmetry, line of symmetry, number of lines of symmetry is 0. Line of symmetry, number of lines of symmetry is 0, right? Now quadrilateral. Now here you have to remember that quadrilateral means having 4 sides. That depends on the shape. Where, so here you see that it may be square, it may be rectangle, it may be rhombus, it may be parallelogram. That is depends on the shape of the quadrilateral. If we take any quadrilateral, suppose apposite quadrilateral, then suppose this is a quadrilateral like this. If we take quadrilateral like quadrilateral 4 sides, suppose this one, if we take a quadrilateral like this, it has 4 sides, right? It is actually it is a trapezium, but it depends on that, right? That means it depends, that is depends on the quadrilateral, which type of quadrilateral it is, and then we find the line of symmetry. But if we take a haphazard quadrilateral like this, for example, we'll draw a quadrilateral like this one, any quadrilateral like this one, suppose like this one, right? Here I am drawing a quadrilateral 1, 2, 3, 4. So 4 side, Y, A, B, C, D. Here in this case you see the line of symmetry is also 0, right? But in a special case, suppose it is a square, then it has 4 line of symmetry. If it is a rectangle, it will be 2 lines of symmetry. If it is a rhombus, it has 2 lines of symmetry. If it is a parallelogram, it has no line of symmetry. That depends on the quadrilateral, right? But you can, if you take any quadrilateral like this, then the line of symmetry is 0. But it depends on the type of quadrilateral, which type of quadrilateral you have taken, that depends, and that is line of symmetry is different for different quadrilateral, right? Now question number H, I and J. Now question number I, see here, question number I is, question number I is a regular hexagon, a regular hexagon. Let us take a regular hexagon. I, a regular hexagon. Let us take a regular hexagon, a regular a regular hexagon, a regular hexagon, a regular hexagon, and J is a circle. J is a circle, a circle, right? Let us take this one. If I take a regular hexagon, then regular hexagon means 6 sides. Here we are taking a regular hexagon, it has 6 sides, right? If we draw the various diagonal, then you are getting here that in regular hexagon there are 6 line of symmetry, right? Let us draw here. Number of lines of symmetry is number of lines of symmetry, number of lines of symmetry, number of lines, number of lines of symmetry, number of lines of symmetry. If we draw the various lines, you see here we are taking this one like this. Fine, take the corners. Take the corners. This is one line of symmetry, right? This is one line of symmetry, right? Next one, you take the corners first. 1, this is 2, this one vertical, vertical line, vertical line, this is vertical line, this is vertical line, 2. Next one, this one. Next one is this one, 2. This one is this one is 3, right? And if we do another line in this way, that is 3. Now this one 3, this one is 4, this one is 4, right? 4. Now this one is 5, this one is 5, this one is 5, and this one is also 6, that is the horizontal. And in this case there are 6 lines of symmetry. In this case there are 6 lines of symmetry. Here you see this is another line of symmetry at this one, and we are getting actually there are 6 lines of symmetry. That means the number of lines of symmetry is 6, right? Now if we take a triangle circle, what will happen? You see, if we take a circle, let us remove this one. If I take a circle, let us take a circle here. This is a circle. Let us take this circle here, right? If we take a circle, then we can get as many lines of symmetry, the infinite lines of symmetry. Let us draw some of them, right? Suppose this one, one, right? Or you can draw another line of symmetry like this. You can take vertical line also. You can take many, that is infinite number of lines of symmetry. You'll find here that this one 2, or you can take like this 3, or you can take like this, you can take it like this 4, or you can take infinite number of lines, right? In case of circles you can take infinite lines of symmetry, right? Here you see you can draw infinite lines of symmetry. Here you see this one like this, or you can draw also like this. Right? That means you can say that number of lines of symmetry for circle is infinite. It is infinite number of lines, infinite. That is infinite. Infinite number of lines of symmetry. Dear friends, if you like this video, please subscribe, like and share. Thank you everybody for watching this video.